Okay, chapter 6, exponents and polynomials. And section 1 of chapter 6 is adding and subtracting polynomials. So we're going to start by getting a little bit familiar with the terminology. I'm not necessarily going to test you on these definitions of the terminology. You won't have to write out definitions, but you do need to know and understand them enough to follow the directions, and that's where the vocabulary comes into play. So the instructions say to identify each polynomial as a monomial, a binomial, or a trinomial, and then give the degree of the polynomial. So let's first talk about the vocabulary here that they're using. Nomial is a way to say the name or how many terms of something there is. So when you have a monomial, mono means one, so that'd be a one term. If you have binomial, that's two. Trinomial, three. Polynomial would mean literally many, but in this case we use it to do any of them, so more than one. And it's typically used in two ways, either more than three terms or just to talk about the family of polynomials as a whole. So they might talk about monomials, binomials, trinomials, all as polynomials, or they could be referring to something that has more than three. So watch for that. And then the degree of a term, if you have, it's based on the highest variable exponent. So the degree of a term or the degree of a polynomial is you're looking for the highest variable exponent. So it's the exponent of the variable. When you're looking for the degree of the entire polynomial, you look for the highest degree, highest variable exponent. Okay. Now, if you were to have a constant number, a degree of a constant number, say like the number 7, for example. 7, you don't see the variable with it because the degree has to do with the variable, the exponent of the variable. But the variable is hidden in the sense that 7 is the same as if you had 7x to the 0, because anything raised to the power of 0 is 1, and that's something we'll look at even more so later on, but should have been something that you've hopefully been exposed to a little bit by now. So that just equals 7, and so the degree here would be 0. So the degree of a constant number equals 0. The degree of a term that involves a variable with an exponent is the exponent of the variable. So the only case that's left is, does the actual number 0 have a degree? And this is not defined. So this is an undefined term because when you have just the number 0, there's no polynomial here, so there really is no degree. Okay. So let's look at a couple examples here. On page 347, number 4, you have x to the 5th minus 7x, and you identify it. Each polynomial is a monomial, binomial, or trinomial. We have two terms here, x to the 5th and 7x. Literally, terms mean anything separated by a plus. Separated by a plus sign. In this case, recall that subtraction is the same as adding the negative of that term. So here's the plus that divides up the two terms. You have x to the 5th and negative 7x as your two terms. Those are being added together. If you're struggling at all with positive and negative numbers, make sure you get some extra help. You want to be really clear on that relationship between subtraction and negatives, positives and adding, all those different nuances that come with being really confident with your positive and negative numbers and how to write that. There's lots of different ways, lots of ways to think about it. Okay, so in this case we do have two terms, so that means it is a binomial. And the degree, we look at the exponents of each of the variables. When you don't see it, it's an exponent of 1. 5 beats out the 1, the 5 is bigger, so the degree here is 5. So it's a binomial with a degree of 5. Okay, let's do another one. Page 347, number 16. negative 11 y to the 26. Yes, there's a minus out here, but there's no other term being added or subtracted. So this is just a single term. This is one term, which we would call a monomial. And then the degree, again, is your highest exponent of the variable. If there were more terms here, we'd be able to compare, but with the one term, we just take the degree of the variable. So our degree here is equal to 26. Take a moment, do your TQC, your tell, question, and copy, and then try this one, number 12, from page 347. Pause the video for a moment so you can try it on your own, come back for the answer. Okay, and after you've tried it, you should establish that it's 3 terms, so it'd make it a trinomial. And the highest exponent is the y to the 5th, so this has a degree of 5. Not always the first term, it is the highest exponent for the variable.